Welcome back to particles. In this video, we're going to make our next particle, which is going to be water. Now, here's where we're at. We currently have three different particles. One is empty, which is kind of the default particle. The second one is metal, which doesn't really do anything, it just kind of sits there. And the last one is sand, and sand again just kind of falls like this. Now, what is water going to do? Well, water should also fall, right? Water is kind of affected by gravity, but I think water, unlike sand kind of falls straight down. Water, we're going to have spray outwards. So instead of falling straight down, water is going to also randomly have this chance of moving to the left or the right. And it'll kind of have this cool effect, like I just said, of water kind of cascading outwards, not just straight down. So let's go through the full pipeline of how I make a new particle. Let's first open up Particles Program. At the very top here, the first thing I always need to do is make a constant. So let's do public static final int water equals 3. And I haven't really talked about this, but these constants are what allow us to differentiate between the types of particles. So it's actually really important that each one has a constant so that when I'm checking later on what is the type of this particle I'm trying to step or do something with, I can actually refer back to this. The second thing I have to do is I need to add this to the array of buttons. And again, this is this array of names. This is what makes the buttons on the screen for each particle. So here, I'm going to say names bracket water equals water. Cool. So now we've made water. Now, there's one problem with this. There hypothetically should be a button on the screen, except that I just added a fourth element to an array that was 3 long. So I do need to change this 3 to a 4. I just added one more thing to it. The next thing I need to do is scroll down and go in the method location clicked. If I've selected water and I click on the screen, I need to add a new water particle. So let's do if particle type equals water. We're going to say grid row call equals new water. And this is not going to compile right now. Why is that? Oh no, I don't have a class called water. So let's go ahead and actually create the water class. And same way we've done this before, we're going to go over here and I can actually duplicate any of these. So let's just duplicate sand since it's over here. And I'm going to call my duplicated class water. I'm going to open it up. And remember, there are 2 things I need to change here. The first is this refers back to whatever the constant is inside Particles Program. So this needs to say water. And the second is the color. Water isn't yellow unless we have a severe problem going on. So let's change yellow to, you could do color.blue, that makes it kind of a dark blue color. I'm going to do color.cyan, which is actually kind of a nice turquoisey light blue color. You should be able to compile this, and we can go back into the Particles Program. And now that I'm in here, I should now actually be able to compile this, and let's actually run this. And right now I'll have water. Great, I can click on it and add it, and it just kind of draws on the screen. Now, how do we actually make water do something is, don't I actually have to go down to the next method here called step and make something happen when I'm stepping water? Yeah, that's what I did for sand, right? How does sand behave is sand tries to fall, right? If I do sand here, right, sand falls down. How is water going to behave? Sometimes it will fall downwards and sometimes it will actually fall to the left or fall to the right. So let's do this. Else if particle.getType equals water, we're going to do something called water behavior. I don't just want to do try to fall down because it's not exactly that. Let's pass in the row and the column to that. So let's write this new method called water behavior, public void water behavior. Int row, int call. Okay, now how does water behave? Well, we've been kind of saying the same thing this full way through, which is most of the time, or maybe not most of the time, but some of the time it's going to fall down, some of the time it's going to go to the right, and some of the time it's going to go to the left. How am I actually going to decide what it's going to do is, well, I don't want all water particles to behave exactly the same, so let's decide that randomly, right? If I just say like the first time it falls, it goes right, second time it goes left, third time it goes down, every single water particle is going to fall exactly the same way. That's not very exciting. I kind of want a sort of randomness to how it's going to spray on my screen. So let's do this. I'm going to say int choice, and this is kind of the choice between will it go down, right, or left. And this is going to be a random number that gives me 3 different options. So I'm going to do this. Int math.random times 3. Again, this is a random number that's going to be either 0, 1, or 2. So 3 distinct options. And then I can just do a little if statement here. Let's say if choice equals 0, let's say we're going to try to fall down, row call, else if choice equals 1, let's try to go right, row call. And lastly, else, this would mean that choice is 2. We're going to try to go left, row call. And now we can code these. Now, we've already coded try to fall down, right? And I think that this does what we want, right? It swaps you with the one beneath you, if it can, if I'm not in the last row, and the thing beneath me is empty. Now we just have these 2 methods to write, right? Try to go right and try to go left. So let's do public void try to go right. And again, this is going to be pretty similar to try to go down, just a little bit different since I'm moving right and left, or in this case just right, instead of going straight down. So let's do int row and int call. Okay, what are the things I have to think about if I'm going right? Well, first of all, if I'm moving to the right, what's actually happening to my location? What is the location that's directly to the right of row call? Isn't it actually row call plus 1? So 2 things I need to do. Don't I need to make sure that that location is empty? And actually the second thing here is I actually need to make sure that there is a location to the right of me, and the order of those matters. We talked about that in the last video, where I actually need to check that I'm not about to index out of bounds before I check what's beneath me. Here, I need to do the same thing. I need to check that I'm not about to index out of bounds before I check what's to the right of me. Now, which column is going to be an issue here? If I'm going call plus 1, that means that the last column over on the side here is the one that actually doesn't have 1 to the right of it. So I need to make sure I'm not in this last column. So I'm going to do this. If call bang equals, how do I get the last column? It's grid bracket 0 dot length minus 1. And now I need to check that the one to the right of me is empty. So grid row call plus 1, dot get type, and let's make the screen a little bit bigger so I can see, equals empty. If that's the case, then what can I do? Basically the exact same thing I do here. So particle save equals grid row call. Let's save the one I'm on. Now let's replace that with the one next to me. So grid row call equals grid row call plus 1. And grid row call plus 1 equals save. So again, I'm kind of doing that little swapping, and swapping 2 values actually takes 3 lines of code so that I don't overwrite and then lose the value in my original one. Great. There's try to go right. We have one more one to write, which is try to go left. Let's do public void try to go left. Int row, int call. And this is going to be very similar. If I'm moving to the left of me, what's actually happening is, what location is that? It's going to be the same row, right, if I move this way, but the column is actually going down by 1. And which column do I have to be worried about? Which column doesn't actually have one to the left of it is column 0 over on the side here, the first column. So I always have to check that first. Remember, you protect yourself before you're trying to access the index in the grid. So let's do if col bang equals 0 and grid row col -1 dot get type equals empty. Let's do particle save equals grid row col. Let's do grid row col equals grid row col -1 and grid row col -1 equals save. So again, all three of these methods are pretty similar, and what's really important here is the bounds checking that I'm doing, being really, really careful that I'm not going to index out of the bounds of the grid. All right, let's compile this. You might have to close out if you still have your particles game running to compile, and let's run it again. And if I run this again, I think I should get water that kind of sprays downwards. So let's run this program. Let's click water. And whoa, that's kind of cool. It's kind of fun to look at, right? It does kind of spray in a way that sand really doesn't. It kind of has a satisfying sort of pattern to the way that it falls. The randomness makes it kind of fun. Now, there's one little thing that is hard to notice unless you test this out with the other particles that's going to be a little weird right now. So if you've sprayed some water on your screen, go ahead and click on sand, and let's drop some sand down. Oh, weird. Right? This isn't really the behavior that I want sand to have. What should sand actually do? Shouldn't the sand kind of fall down into the water? I mean, sand definitely doesn't sit on top of water in real life. Now, why is this happening? Let's look at how does sand behave as it tries to fall down. So let's look at try to fall down. When will sand try to fall down is if it's not in the last row and, oh, here we go, the one beneath it is empty. So how should I actually change this? When should I get to fall down is when the one beneath me is empty or it's water. So I think I need to change this a little bit. So I'm going to type this. Let's go on the next line just to make our lives a little easier. Or grid row +1 col dot get type equals water. Now, I've done one subtle thing wrong here. And that one little thing that I have done incorrectly is that, remember, if statements have an order of operations to them. So there's actually a precedence between which one happens first, and versus or. And if you remember kind of nothing about this, if this is a hard thing that sticks in your brain, you can always just think of it alphabetically. They go in alphabet order. So and starts with an A will happen before or, which starts with an O. So I'm going to have a little bit of a problem here because the first thing I'm going to do is this and that together or just this. And really what I want to do is check the bounds for both of these statements, right? I kind of want to check these two together, right? It's either empty or it's water. And also I've checked the bounds for both of them. So I think I actually really need a set of parentheses around this whole statement here. So let's compile this and run it. And I think this will fix our little sand sitting on top of water problem. Let's see. If I run this and let's just kind of drop a bunch of water in. Woo, there we go. Make a nice little pool on the bottom here. And then let's add some sand, and you can see now the sand does actually kind of go to the bottom and displace the water as it falls. Cool, so there's water. Again, not all that different than how sand works, but it is a little bit more complex. Now I can kind of go down, right, and left, and it has this fun little pattern to kind of the way that it falls. It's a little satisfying. In the next video, we're going to make the particle ice, and I want you to think about how is ice going to behave. This is going to be the first time where we don't just duplicate one of these classes, we're actually going to add some stuff to it, so it's going to be pretty interesting.